Right. Morning, everybody. Can you hear me online? Hello? Hello? People online, can you hear me?
Yes, sir.
I can see the screen as well.
Yes, sir.
All right, good. All right, guys. So we're gonna work through the paper that I sent you. We're not gonna do all of it. We're gonna do about 4 of the questions today, another 4 questions tomorrow. And I'm gonna send another page of questions to do. Can you throw away the phones, please? Put away the phones, please. All right. Now, really and truly, you guys are supposed to do these questions before I do them. All right. So we're getting to that stage now, but we're going into January now. Finish the first half of the program. We're going into the second half of the program. So where you guys were not following the instructions to the T with respect to doing the question before I do them. We're getting to the stage now where you actually will have to do the question before I do them. Because it means that the time for revision, the time for catching up, time to close gaps is now reduced significantly. You don't have time now for me to be doing a topic in the class for it to depend on a revision period to get it. You have to get it as it is start, as you do it. And the best way to get it as we do it is to actually do the work. Right? So it has to be going forward. When I give you work to do, you have to do it before I do it. So that when I do it, you learn from your mistakes. All right, because you won't have time, you won't have the luxury of time anymore. All right. So where it's gonna go? I'm gonna work through this paper, and I know the majority of you would not have done it. You can sit here. You can sit here. The majority of you would not have done it. All right, because of a short window of time. But I wanted to do it even after I do it. That's the important thing. And the good thing is that this session is being recorded. So the recording will be available. And you can use the recording to assist you where necessary. Right? You have to do the questions. You absolutely have to do the questions. Watching me do the questions is not enough. As easy as it looks when I do it, it's just not enough. Right? You're gonna find it not as easy when you are doing it. For it to become easy, as it actually is, you have to practice a lot of the questions. You have to put pen to paper and actually do the questions. So these very questions, when I'm doing it and I'm explaining what I'm doing, it's an easy flow. I'm telling you what I'm doing and you're understanding it. You doing it on yourself knows a different kettle of fish. For it to become that easy as it is, when I'm doing it, you have to practice the questions. All right? So you absolutely have to go and do it, even if you understand after I do it. You have to go and do it on your own. All right, so enough of that. All right, so it's just a matter of working through these questions and then, just saying back some of the stuff that I would have said when I taught the topic initially. All right, each of these topics initially, somebody call them, I can't take this call. You have to work it out. All right, so this first question up here is just a pair of simultaneous equations to solve. This one is a curve, this one is a line. This is actually a quadratic curve, as you can see with the x squared, and it's a smile-shaped quadratic curve. That's a line with a positive gradient. So you must have all these kind of idea now, right? Because the 2 on this is positive. So there's a positive 2 gradient. So the line's open like that. And so you're possibly gonna have 2 points of intersection. And that's what we're solving here, a simultaneous equation. Now, normally we would say solve simultaneous equations by substituting a line into the curve. But the beauty about this one is that y is the subject of both of them. And so at the points of intersection here and here, the y values are the same. And so it means that this expression equals this expression at those 2 points of intersection. All right? So basically that's the approach we're going to use. We're going to equate the 2 of them. Like that. All right, so let's go. So we have y equals x squared minus 3x minus 12. And we have y equals 2x minus 6. So at these 2 points of intersection, we can equate this one with this one. It's actually 16. So it's going to be x squared minus 3x minus 12 equals 2x minus 16 at the point of intersection. That's a quadratic equation, you know. Remember, when we're solving quadratic equation, we want the expression to be equal to 0. And so we need to take these two expressions and transpose them onto this side to get a standard quadratic equation equals 0. All right, when in the form where it is equal to 0. Then we can use the method of factorizing to solve it, or we can use a quadratic formula. So if I take this 2x and bring it over this side, it's going to become negative 2x. The negative 2x with the negative 3x is going to become negative 5x. So this x squared term stays the same. Then I have negative 5x. When I bring this over here and put it at that. And then this negative 12 is here. I'm going to take this negative 16, bring it over here. It's going to become a positive 16. The positive 16 and this negative 12 gives me a positive 4. I'm going to get a positive 4 over here. And that is now equal to 0. Now you have it in the standard form. You're ready to solve by factorizing. All right? So this is easy to factorize because the only factors of the x squared are x and x. And the factors of this 4 that add to 5 is 1 and 4. All right? And after a while, you start to do this thing shortcut. There's a factorization question on the paper that I'll use the process. But for this one, this can be factorized on site. This tells me that I want the sum of my far product and near product to be equal to this middle term. It also tells me that the two signs in the bracket are the same, and both of them are going to be negative. I'm going to factorize this now. So it's going to be x and 1 and 4. This tells me, as I said, the two sides of the bracket are the same. Both of them are negative, negative, negative. I can check it because the far product is negative 4x and the near product is negative 1x. Negative 4x and negative 1x gives me the middle term of negative 5x. So I know that factorized correctly. All right. And then remember now, if you have the product of these two factors equals 0, then it's either this factor equal to 0, and if that factor is equal to the 0, then the x is equal to 1. And if this factor is equal to 0, then the x is equal to 4. So those are just the two x values now at these 2 points. That's all that is right now. The two x values at those 2 points. All right. So here the x value will be 1, and here the y value, the x value will be 4. And so we need to find the y value here and the y value here now. To find those y values, you tend to substitute these x values back into the equation of the line. It is easier to use the line equation to get the corresponding y value. Always use the line equation. All right. So we're going to substitute back in the line equation there. So we can actually just plug the values in there and say, and y is going to be equal to 2 times 1 minus 16 for this one. And y is going to be equal to 2 times 4 minus 16. So this one is when we substitute the 4 in this. And this one is when we substitute the 1 in the same line equation. All right, so we're doing the math like big people now, you know. So this works out to be 2 minus 16 is negative 14. And 8 minus 16 is negative 8. So the solution values are 1, negative 14 at 1 point. You can put that as a point. The solution is 1, negative 14 for 1 point and 4, negative 8 for the other point. And that is your solution. Everybody good at that? Online, everybody good at that? I was trying not to forget the online people, you know. So always happen. All right, that is it. One question though. I want to do about 4 questions today because I just want to be focused right through. I don't want to come to a point where you lose focus and so on, right? So I don't want to do 2. I don't want to do maybe 4 questions from the paper today and the next 4 tomorrow. Because I want us to have a quality session. All right, so the next question is our standard quadratic. They give us this quadratic, which is the same quadratic here, and I want us to write it in this form. Now note, let me just highlight something to you, that this time they give a minus there. Now most papers, they're going to put a plus right there. Most paper, they'll put a plus. So depending on the method that you learn, calculate the H and the K, this minus can present a problem to you if you're not mindful of it. So when the teachers teach you that H is B over 2A, they teach it that way. The B over 2H is on the premise that this is a plus. If you learn it that way, that's a plus. So when they present with a minus there, the H then becomes negative B over 2A. So you have to note the difference. So the safe thing to always do is to do it the same way every time. That's why in this class, I introduce the XT, YT, because CSEC tend to change how they present that expression from time to time. And sometimes, it can create confusion. All right. So I'm going to use the method XT, YT as we have done. All right. So for part B, the expression is y equals x squared minus 3x minus 12. I'm going to write it as a into x minus xt squared plus yt. That's what we did in the class. That's our method. So there's no confusion. Let me make this small and zoom. There's no confusion when we do it this way. Right? There's no confusion when we approach it this way because we know that we can calculate the xt and the yt using formally connecting the A, the B, and the C from the standard form. All right, so the A in this expression is equal to 1, the coefficient of x squared. The B is the coefficient of the x right here, which is negative 3. I have to see the sign is negative 3. And the C is a constant term, which is negative 12. Negative 12. And then now the xt that's coming here is minus b divided by 2a. That's the method that we're using. And so it becomes equal to, put down this minus first. And then this b is negative 3. So it becomes minus a negative 3. This minus becomes a plus divided by 2 times a. The a is this 1 right here. That becomes a positive 3 over 2. That's the xt. And then the formula for yt now is 4ac minus b squared divided by 4a. That's a formula for yt if you're using this formula method to calculate the xt and the yt. I will substitute in the values again. So this becomes equal to 4 times the a. The a is 1 from here, times the c. The c is this negative 12. Let's write that better. Minus, remember, this minus is not squaring. You're only squaring the b. So this minus will remain a minus, and then the b is a negative 3. So you're squaring a negative 3. And put in all of that over 4a. 4 times 1. And then consolidate the values now. So this is 4 times 1 is 4. And then 4 times 12 is 48. So it's a negative 48. Minus, remember that this minus stays a minus. That's what it is. And then this negative, I put a cube. Oh my goodness, I'm not doing them, so I put a cube squared. And then this negative 3 squared becomes a positive 9. And dividing all of that by 4. So this negative 48 and this negative 9 is now negative 57 all over 4. So this xt value is coming here. And this yt value is going there. And so we have those values and the a is 1. So we have those values now. We are able to write the expression. So this thing now becomes y equals, the a is 1. We don't need to put the 1. If you want to put it, no problem. Into x minus the xt, we say it's 3 over 2. Don't forget to put on the square. And the plus yt is negative 57 over 4. So we can just write minus 57 over 4. And that is it. We have completed the square. All right. So that finishes that part of the question. The next part now says, hence determine the minimum value. The minimum value is always a yt value here. The minimum value of the function and the value of x for which the minimum occurs, right? For which this is minimum. So it's xt and yt they're asking you for. So the yt is the minimum y value. Lowest y value on the graph is the yt value. So for part 2, minimum value is the yt value as always. the y value at the turning point. If it's a frown, that will be the maximum value. In this case, it is negative 57 over 4, which occurs when the x is equal to the xt value. And that xt value is 2 over 2. 2 over 2. So in other words, if you take 2 over 2 and can test it for yourself and you substitute it in this function, it's going to work out to this yt value. Right? And you can literally see it in this form. You can see it in this form better. Because if you take this x value and put it as 2 over 2, and 2 over 2 minus 2 over 2 is 0. So the y value just becomes that negative 57 over 4. And we want to look at it, that is what it is. All right? So that is the answer for that one. So that is the minimum value. And this is the x value where it is minimum. All right, so that finishes that part. Next part wants us to calculate, correct the one decimal place, the roots of this equation. And it's the same function and it's the same function. So remember the roots now are the points where the graph intersect the x-axis. The x values where the graph intersect the x-axis. And the reason why they tell you to correct it, get it correct to one decimal place is because you're not going to be able to factorize the expression. You won't be able to factorize it. You have to use either the quadratic formula, or you can actually do it from this. You can actually do it from this right here. From this form. You can actually find it from this by putting this equals 0. Because it's the same expression. But let's just practice with the quadratic formula. Right? And that's why you're going to see these similar values coming out when you use the quadratic formula, the 57 and so on. So for part 3, when I use the quadratic formula, for those who don't remember, you have an equation ax squared plus bx plus c equals 0. Then the x is equal to minus b plus or minus the square root of b squared minus 4ac. Remember, it's everything over the 2a, all over 2a. The mistake a lot of people make is that they put this part alone over the 2a, which is wrong. It's all over the 2a, everything over the 2a. All right? So in this equation that we're solving now, which is x squared minus 3x minus 12 equals 0. That's this equation right here. The x is going to be minus b. The b is negative 3. Plus or minus the square root of the b again squared. That's a negative 3 squared. Minus 4a. The a is a 1 in front of x squared here. Times c. The c is negative 12. And it's everything over the 2 times a, where the a is 1. And you see that this inside they work out back to the same 57 that we had before. Because this is 9. This minus makes this a positive 48. 9 and 48 is 57. So inside here is working out to 57. So the x becomes this positive 3 plus or minus square root of 57 all over 2. So we just need to work this out now and get the 2 values to one decimal place. X equals. So let me write it out here. So it's just 3 plus or minus the square root of 57 over 2. Let me get the calculator now. Where are you? All right, so it's a fraction. 3 plus, let's do plus first, square root of 57 over 2. So one decimal place, that's 5.3 with the plus, and with the minus, it's a negative 2.3. Because it's a one decimal place, all right? So those are the values. So let's go to minus 1. Negative 2.3. Mute the mic, please. Somebody online, mute the mic. 5.3. So these are the 2 roots, you know. Those are the 2 points where the graph intersect x-axis. And so we have done this part as well. Right? So it's x equals minus 2.3, x equals 5.3. The last part now here, well, this part wants us to make a sketch. We want us to sketch a graph and show where the minimum point is and the y-axis intercept and also the x-intercepts. Right? So remember, the minimum point is xt, yt. The minimum point is xt, yt. So this is going to be xt, yt. That's the minimum point, which in this case is 3 over 2, 3 over 2, and negative 57 over 4, xt, yt. The y-axis intercept, remember, is 0, c. Which in this case is 0, negative 12, because the c is negative 12 on the function, right? So that's a 0, negative 12. And the x-axis intercept are these two values. Right? These two values. And on x-axis, right? So this is talking about these two values. So we can sketch it now. We can make a sketch. Let's make the sketch. Nice and easy. So we know it's going to be a smile. We know it's going to be a smile. Let's put in the y-axis and the x-axis like that. So we know it's a smile, right? The first thing is, where does it turn? It turns at this minimum point. It turns at 3 over 2 minus 57 over 4. That's where it turns. So it turns where the x value is positive and the y value is negative. That's where it turns. So it turns down here. Somewhere down here turns where the x value is positive, positive x, negative y. So we know the turning point is somewhere under here. All right, so we know that so far. So it turns down here. Next point is, where does it cross the y-axis? It crosses the y-axis at this 0, negative 12. So it crosses the y-axis somewhere down here where the y value is negative. All right, crosses the y-axis where the y value is negative. So you want a smile that turns here and crosses somewhere down here. So all you need to do is just draw that like that. It is not to scale. So this point, we're going to put as the minimum point, 3 over 2, negative 57 over 4. Cross the y-axis at this point, 0, negative 12. And then these are the two roots. This is clearly the positive one, which is the 5.3. And this is the negative one of negative 2.3. And that's a sketch of y equals x squared minus 3x minus 12. That's a sketch. What about that? Nice and easy. The question asks for the axis of symmetry, remember, it will be the vertical line through here. And it will be x equals the xt value down here, which is 3 over 2. That will be the axis of symmetry. If they wanted the axis of symmetry, that is what it would be. Axis of symmetry or the line of symmetry. But they didn't ask for it this time. All right, so instead, what they did on this question, they gave us this little part down here now. This thing. It says, use your sketch to determine a solution set for this. Let me zoom it up and we'll talk about it a little bit. Solution set for this. Remember that this expression is y, you know? So this is basically say where y is greater than or equal to 0. So see, this inequality is asking you for the x values where your y values are greater than or equal to 0. So on this graph over here, which is a sketch of the function, it's referring to these parts of the graph where the y values are greater than 0. Up here, the y values are positive, don't it? That's all. Agreed? And those points on the y-axis are obtained by x values that are to the right of this one. Because a x value out here going to give you a y value up here. Or to the left of this one. So x values to the left of this one or to the right of this one gonna give you y values that are positive. And for the equal 0 part, we already know that it is actually these two values themselves. And so the solution for this is simply where x values are greater than or equal to 5.3 or less than or equal to negative 2.3 based on this. All right, so for x squared minus 3x minus 12 greater than or equal to 0, that is where your y values are greater than or equal to 0. Your solution is that your x values have to be less than or equal to negative 2.3 for your y values to be those, or they have to be greater than or equal to 5.3. That's the solution for that one. And now suppose that asks it the other way around. Now. Let's copy this down. And so suppose that asks it the other way around. They could have said less than enough. We'll copy this. Paste it here. Now suppose instead they asked it this way. So let me take these off. All right, suppose the inequality was instead this. X squared minus 3x minus 12 less than 0. Or it could be less than or equal to 0. Let's take the equal off this time, just less than 0. Then this now will be referring to where your y values are less than 0. Meaning where on the graph are your y values negative. Your y values on that graph are negative down here, below the x-axis. So that inequality we're referring to this part of the graph now, this one. But understand that. And where are your x values that will give you these y values, these negative y values? It is the x values that are inside here, this way, and to the right, this way. So x value in between these two values. Any x value in between these two values are going to give you these negative y values. And so the solution would be your x values being between negative 2.3 and 5. And that is one continuous interval of values. And so the solution for this one would be where x, they like to put an x value inside here. Your x value inside will be less than this one over here, which is 5.3. At the same time, the x value inside will be greater than this one over here, negative 2.3. So that is the solution. Your x value would have to be less than 5.3, but greater than the negative 2.3. And if this had the equal on it, then you just put the equal on this range of values as well. All right, so that will be your answer right there. For that one, if they gave you that. Because they could have given their question like this as well. But all right, one question though. Miss Scott, you go to swim out the whole of your energy, man. Eh? You swim today? What distance you swim? Eh? 50? So 50 times make it tired, so. Just 50 meters. Can you have to do it fast, 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 fast? Eh? Jesus, so swimming hard. You have to swim 50 meters and then come class for 3 hours. That's rough enough. Yeah. So I've heard people with the sports. Yeah. All right, buddy, good. 1 down, 3 to go.
Yes, sir.
All right. So remember, it's recorded. So if anything, all who feel sleepy, all who swim 50 meters and sleepy, can go and watch a video when you wake up and more fresh, right? And if still you don't understand something, you send me a message and say, sir, can you explain that part again? Because we have to get past all of these things now, guys. All right, the next time we're coming back to these topics is in March. After we go through this revision of everything we did in September, we're really going to delve down into them again in March. Yeah, we're going to touch them on a weekly basis when we do pass over questions. But in terms, and we're just going to be working the questions as you would do in an exam. So all this work for explanation and different permutations how to set the questions, no. Just basically just doing the questions as I would expect to do them in an exam room. So as a basis of the revision. So that's how we get a continuous revision. All right. So if you understand something, let me know. All right. Next question is functions. Fun topic. Functions. Right on the screen here. Let's go. Right. So this question gives us these two functions, f and g. This one is your rational function. This one is your simple linear function, f and g. The first part wants g of 4. It means that you're going to put 4 in the g function. Now it's an easy. All right. And then I want f of g of 2. Let's do this g of 4 first. All right. Let's go. So let's write them out. So it's f of x is 2x plus 5 over x minus 4, and g of x is 2x minus 3. And the first part wants g of 4. Easy. I always do that, you know. I always give you a simple one. So you're going to plug the 4 in the g function right there and see what the image value is for that 4. So it's 2 times 4 minus 3. That's 8 minus 3 is 5. So this answer is 5. Nice and easy. Part 2 wants f of g of 2. Remember that f of g means g followed by f, just like in transformation. We're doing the g of 2 first. So this is the same as f of g of 2. I'm going to work out the g of 2 first. All right, we have to do the g of 2 first and then apply the f. So we're going to do that by plugging the 2 inside here. And so it becomes f of 2 times 2 minus 3. That's 4 minus 3 is 1. So really now we're working on f of 1. And f of 1 now is found by plugging 1 in the f function where the x is here and there. Those 2 places. All right. So that now is going to become 2 times 1 plus 5 over 1 minus 4. This up here is 7. This one here is negative 3. So it becomes 7 over negative 3. You can leave it like that. 7 over negative 3. Body good? Online, body good? Don't forget, you know, have to talk up, you know.
All right, sir.
Beautiful, beautiful. All right, so done part 1 and 2. Part 3 says, state the value of x for which f of x is undefined. So remember, the function is undefined when the denominator equals 0. Function is undefined when the denominator equals 0. Another way you could phrase this question, the same question, is to say, what value of x cannot be in the domain of f of x? What value of x cannot be in the domain? The function cannot have 4 in it because 4 is going to make the denominator become 0. And then you can't work on the f. And for the function to work, you have to be able to work out your y values. So any value that causes you not to be able to work out your y value is not a part of the function. All right? So x cannot be. Remember, for a function to exist, each element on the domain must map to a value in the codomain. Right? And the 4, if it is in the domain, it would not have a value mapping onto, because there's no value that exists for 4 to map onto. And so since you have a value in the domain that is not mapping, you would not have a function. Get me? So for f to be a function, 4 cannot be in the domain, because 4 will make the denominator 0. Okay, can't divide by 0. So let's see it here. F of x is undefined or not defined. when the denominator x minus 4 is equal to 0. That is when the x is equal to 4. So 4 cannot be in the domain. All right, so let me write that. Therefore, 4 cannot be in the domain of f of x. 4 cannot be in the domain because 4 would not have a value mapping onto. Remember, for a function, for a mapping to be a function, each element in the domain must map, and it must map only one time. 4 would not have a value mapping onto, and therefore 4 would cause f of x to fail as a function. I will call that expression to fail as a function because it would not map to anything. All right, better go to that. All right, so that is the revision. Next part now wants us to find f to the minus 1 and hence solve this. So this is now using inverse function to solve the equation. And we did that in class. All right, so let's look at part 4. So first thing we want is the inverse of this function here. Inverse. To get the inverse of that function, remember the method we use is to interchange the domain and the range. Some teachers interchange the x and the y and all of that. Any method they use, you're going to have to transpose and interchange and transpose. You have to make whatever is in this position the subject. Any method they use to do it, that thing in that position has to be transposed into the subject for you to find the inverse. Whether the teacher use x and y or f to the minus 1 or them transpose, make it the subject first and then change it. It doesn't matter what method they use. The method must involve interchanging or transposing this to make the x the subject. All right? That position, that variable in that position, the subject. The method that we use in this class is to call it f. Call the function f. Just drop out the of x for the time being, which is 2x plus 5. And if you do it another way and you get in the right answer, don't have a problem. Just make sure you get it right when you do. All right. Mute the mic on the call, please. Mute the mic. And then that is the function. And then we say we mute the mic, please. Mute the mic online. And then that is the function, and it will form the inverse. When you form the function, when you form the inverse, this on the function represents range. It becomes a domain. This 2x's on the function, they represent the domain. They become range on the inverse function. Range on the inverse function is written with a f to the minus 1. So it becomes 2 times f to the minus 1 plus 5 over f to the minus 1 minus 4. And then now you really want to now make this f to the minus 1 the subject. That's what it is. So to make f to the minus 1 a subject, you don't want them to be dividing each other. You want to be able to separate all the terms. So the first thing you want to do is expand this out into separate terms so that you can group the terms in f to the minus 1 on one side. So I'm going to take this denominator and multiply it across here by the x first. When I multiply it across here by the x, it is x times this value, and then x times that value, x times each of them. All right? So it becomes x f to the minus 1, and then the x times this minus 4 is negative 4x. And that leaves this on the right side, 2f to the minus 1 plus 5. But I go to that so far. And then now we want the terms in f to the minus 1 on the same side. So I'm going to leave this one where it is, and I'm going to take this one and bring it over here. Then this first, I don't want it. I'm going to take it and bring it over that side. Simple transposition. Transpose and change the sign. All right? So I'm leaving this one on this side, x f to the minus 1. This one comes over here, becomes a minus. So it becomes minus 2f to the minus 1 equal. This 5 remains a 5, a positive 5. This 4x comes over and becomes a positive 4x. So I'm now getting a positive 4x over here. Then to consolidate the f terms here, so you can have one f term in there, we're going to factorize the f. or the f to the minus 1. So you factorize the f to the minus 1. Out of this, I'm getting an x. Out of this, we are getting a negative 2. And that becomes 5 plus 4x. And then to leave f to the minus 1 as the subject, we take this and let's divide it on the right side. Same as say we divide both sides by it. Same as say we divide both sides by the x minus 2. So what happens then? You get f to the minus 1 equals 5 plus 4x over the x minus 2. And that is the f to the minus 1. I'm putting back up x now at the end. And that's it. That's f to the minus 1. The inverse. Them say now we must solve this. And they say hence. Hence means you have to use the f to the minus 1 to solve this. All right, so let's look at it now. So remember, this using inverse to solve an equation, right? It's based on this. This is like a rule that you must know for it works only for one-to-one function because only a one-to-one function can have an inverse anyway. All right. So if f of x is equal to any number, then the x equals f to the minus 1 of that number. It works the other way as well. If f to the minus 1 of x equal a number, this is f to the minus 1 now, then the x equal f of the number. Right? So if the f maps x to n, then f to the minus 1 maps the n back to x. That's how it works, either way. All right, so for this question, what we have right here, you must recognize that this side of it is really f of x. So we're really solving f of x equals minus 1. All right, so this thing that they gave us, right here, this thing is really f of x equals minus 1. And try to make the x. So if f of x equals minus 1, then the x that you want is f to the minus 1 of negative 1. So to get f to the minus 1 of negative 1, we're going to plug the minus 1 in the f to the minus 1 function right here. Just plug it in there. So put the minus 1 in there. So it becomes 5 plus 4 times minus 1 over minus 1 minus 2. This is a minus. This is a minus 4. Minus 4 and 5 becomes 1. Same as 5 minus 4 is 1. And I use a negative 3. So this works out to be 1 over negative 3. That is it. Or negative a third. That's the answer. Quick and fast, yes? Use another way and get negative 1/3. That's the same, no matter. Yeah, man. Negative 1 over 3. Same as negative a third. Anyway you want to put it. Same thing. But the only thing, that the question said hence. So I don't know if you actually use hence. The hence means you have to use this thing that I just asked you for. So that they are forcing you to use the inverse by saying hence. The question said hence or otherwise, then you could go along and solve this by itself. So I don't think that's what they wanted to do. They wanted to use the inverse that you just calculated. So this question is forcing you to do it this way. To do it this way. So if you didn't do it that way, yeah, you wouldn't get the marks for it. But the question clearly said hence. If it said hence or otherwise, then you could go and do it another way. All right, so learn from that. All right, the next part now says we have to find g to the minus 1. I must use it with the f to the minus 1 that we have to find this. So this question now, this is inverse, right? This is actually inverse. So this question now is testing your knowledge of inverse of a composite function. That's what this question is testing. Inverse of a composite function. All right, so let's write down the f that we have first. So we have this first, the f to the minus 1 right here. We have this already. And they're asking us to find the g to the minus 1. Remember that the G is this, you know. So we're going to start by saying the G equals 2x minus 3. We inverse the G. X becomes 2 times G to the minus 1 minus 3. Then to make this a subject, we're going to transpose the 3 and then divide under the 2. So we're going to get x plus 3. We'll carry over this 3. Then take this 2 and divide it under there. That is your G to the minus 1 of x. All right? So G to the minus 1 is equal to that. Then they want us to find now G of f r to the minus 1. That's what they want next. Now you have to know that G of f r to the minus 1 broken out is actually equal to f to the minus 1 of G to the minus 1. So the inverse of a composite function is equal to the composite of the inverse functions. The key thing is that they are switched around. So if you have G in front here, it goes second there. If you have F second here, it goes first there. That's the key thing to remember. So we're using these two functions now in this calculation. How do we do this again? We put the G to the minus 1 into the F to the minus 1, meaning we're taking this G to the minus 1 or substituting it into the F to the minus 1. There where the X is, and there. That's how we put the G to the minus 1 into the F to the minus 1. All right? That's how we put the G to the minus 1 into F to the minus 1. So then this works out to be, let's go back for the red, works out to be the 5 plus 4 times x plus 3 over 2 all over x plus 3 over 2 minus 2. That's it. That's GFR to the minus 1. But then I'm expected to simplify. This can be simplified. I'm going to multiply top of numerator and denominator by 2. So if I multiply numerator by 2, I can get rid of this one, even though this could get rid of it, you know. But I'm going to get rid of this one by multiplying by 2. So I'm going to multiply the numerator by 2 and multiply the denominator by 2 to get rid of those fractions. All right, so this becomes 2 times this 5 first gives me 10 plus 2 times this fraction cancels this 2. So it becomes 4 into x plus 3 over 2 times this fraction cancels away that 2. So it becomes x plus 3 and 2 times this negative 2 gives me negative 4. So if we simplify this now, it becomes, this is really 4x plus 12. This is really 4x plus 12. So it's going to become 4x plus the 10 and the 12 is 22 over, this is really 3 minus 4 is negative 1. X minus 1. That is it. That is it. That's the answer right there in simplified form. But all right to that, I'm more interested in the process rather than the answer. And this is the key thing that I wanted you to remember, this thing. Right here. This question is testing your knowledge of this thing. Inverse of a composite function. So if you didn't remember it before, yeah, revising it now. Bringing it up, bringing it back in your head. All right. All right, so we have a little simple little algebraic fraction there to add. Algebraic fraction. Remember, when you're adding fractions, whether it's numerical or algebraic, the approach is the same. You want the fractions to become related. Related fractions are fractions with the same denominator. All right? So it's a write as a single fraction. In other words, add these into a single fraction. So let's set it up. So it's 3 over x, and put a space, plus 4 over x plus 1. All right? So I want to add these two fractions. I want the two denominators to be the same. So this one, I need this in the denominator multiplying. So I multiply this fraction, numerator and denominator, by this other denominator. So I'm going to multiply this by x plus 1 over x plus 1. And I take this denominator, multiply it up here and down here as well. So the two denominators become the same. So multiply this one by x over x. And what's going to happen is that this numerator becomes 3x plus 3 divided by the product of these two things, x times x plus 1, plus this denominator becomes 4x, numerator, I mean, x times x plus 1 and this denominator as well. So you see now the two of them have the same denominator. And so the answer is going to carry that same denominator because they are not related. And all I have to do is add up the numerator algebraically or numerically. All right, so x plus 4x is 7x. This 3 is not adding to anything, it's just staying by itself. That is just single fraction, like that. Very good. Then I give us this little thing to do, numeric. I mean, you could put that in a calculator if you want. I don't they'll give you that in the exam paper anymore. Well, they can give you in question one for real. Because there are questions on the paper that allows you to just use the calculator to work it out. All right, but this one is testing your knowledge of indices. All right, so let's look at it. Show you something if you didn't know before. So 9 to the half times 8 to the 2/3 times 4 to the 0. Now this half power is square root, because it's really 9 to the 1 power root 2. It becomes the square root of 9 times, watch this now. When your power is a fraction, the numerator is your power and the denominator is your root. The numerator is your power and the denominator is your root. So this means the cube root of 8, cube root of 8 squared. That's what it means. Cube root of 8 squared. And then now, any number raised to the power 0 is 1. Any number raised to the power 0 is a 1. Any number raised to the power 0 is 1. Right? So this one just becomes a 3 times the cube root of 8 is 2. You get 2 squared times 1. This 2 squared is 4. 4 times 3 is 12 times 1 is still 12. So the final answer for this is at 12. That is the answer. So remember, when you raise up a number to a power that's a fraction, the denominator of that fraction is your root, and the numerator is your power. So I've taken the cube root of 8, then I've raised that to a power of 2. And that's it. But the calculator can work this out. If you have a good calculator, put it in exactly as it appears there, and you can get it. Very good. 2 questions down, 2 to go. Time is it now? Yeah, man, we are good time. 12:17. And we never start 11 o'clock. Let's want the 4 questions today. Huh? You want to stop now? Can't go on class with 2 questions alone. Suppose I have 10 questions per class. Why? There's 10 questions in the exam, on your exam paper. It's 10 questions on the exam paper, you know? 10. So you really should be doing 10 questions per class, minimum. But anyway, better go online. But okay? Not hearing anything. Online people gonna sleep. Oh, somebody say yes. Huh? All right, let's go. Next question. Some simple little stuff. Some like algebra, factorization, inequality, linear variations. All right. Everything important. Stop talking now. Hey, stop talking now. Stop talking. Talking and online work well together. Stop talking. Ready? Let's go. First part gives us this thing, and they want us to calculate the value of R when the P is 6 and the Q is 12. All these are partial questions, you know. All these questions are partial questions. All right? So we have R equals 2P squared divided by Q minus 3. The first part is telling us that the P equals 6 and the Q equals 12. Put them in that and find the R. So the R becomes equal to 2 times the P is 6, 2 times 6 squared over the Q is 12, 12 minus 3. That becomes 2 times 36, because the 6 squared is 36, over 9. 36 divided by 9 is how much? 4, don't it? And 4 times 2 is 8. So this works out to 8. So the answer is 8. Nice and easy. I could do 72 divided by 9. Could do that way as well. But after that, nice and easy. Answer is 8. Part 2, easy again. Part 2, easy again. Part 2 gives us the same R equals 2P squared divided by Q minus 3. And it says make Q the subject. Easy. Make Q the subject. But I multiply away this whole denominator up here and take this R and divide it under same time. All right? So we can isolate out the Q. That's the first step. Multiply the Q minus 3 as a whole denominator. We use a color code for you. So I take this Q minus 3 and just multiply it up here. I want to take this R and divide it away same time. When we do that, we're going to get the Q minus 3 as a subject equal 2P squared over the R. But to go to that, then to leave the Q as a subject, now we just take this 3 and add it over there. So nice and easy. So the Q becomes 2P squared over R plus 3. That is it. Now you might have done it another way, and you might have gotten 2P squared plus 3R all over R. To get that same thing. To get that the same thing. Very good. Let me tell you something. See, mathematics, your ability to transpose and simplify expressions is a key to success in maths. Because a lot of persons know the principle to apply and all of that. But their problem is in simplifying what they have or transposing what they have. So if you're able to transpose well and simplify well, you'll be very successful in this subject. So if you know you're weak at it, you need to practice it. Go online and get some of those questions, some worksheets to transpose and simplify expressions and do them. Get some complicated expressions to transpose and make something the subject from it. Right? Practice that. If you get good at that, the mathematics will become very easy for you. All right. Part B, to factorize these things. Let's go. So the first one here, the factorization by parts or factorization by grouping. I'm almost certain we do this particular question already. 3G minus 3T plus 2mg minus 2mt. 4 terms here, so I know the factorization by parts or factorization by grouping. So what you normally do, you normally check if the values are in a friendly order first. You look at the first 2 terms and say to yourself, if I were to factorize the first 2 terms, is your common factor? Yes, 3. What will be in the bracket? It will be the G and the T in that order. So you look at these 2 terms now to look if the G and the T are in that same order, which they are, so you're good to go. If they were not in that same order, you have to rearrange and get them in that same order. All right? That's how you know when you have to rearrange or not. So this don't need to rearrange. Highest common factor in the first 2 terms is 3. You're going to get G minus T in the bracket. Safe thing to do is to put the G minus T in the bracket over here as well. Then look at the factorize out of this. With 2m. And not just 2m, it's a plus 2m. So you factorize a plus 2m out of it. And you can double check. 2m times this, give you that. And 2m times this minus t, give you that minus 2mt. So you know you're good. Then what happens now is that this g minus t is now your common factor. And so these two times that common factor. So the result is 3 plus 2m times the common factor of g minus t. And that is it. Nice and easy. First one done. Second one is your quadratic. And that one I'm going to work through the steps for this one. Right? Now let's work through the steps. After a while, if you get good at it, you can actually look at them and factorize them now. Especially when one of your n values is a prime number, prime factor, like the 3x squared. The only factor of 3x squared is 3x and x enough. So you already have two of your values. But anyway, let's go to the process. So we have 3x squared plus 2x minus 8. I was trying to split that 2x out into two terms so we can create a 4 terms and factorize by parts again. What's the process of doing that? You multiply the 2n coefficients with a negative. So it's 3 times negative 8. That is equal to negative 24. There are factors of this negative 24 that add to the middle coefficient. Middle coefficient is positive 2. So you want factors of negative 24 that add to positive 2. All right? Let's analyze it now. So factors of this negative number, one factor must be positive and one must be negative. And you want to be such that the sum of the two factors is positive, and so you have to give the larger one the same sign as this, positive. And if you can't see what those two factors are right off the bat, it's 4 and 6, you know. 4 and 6. Right? Right off the bat. But if you can't see what it is right off the bat, then you can go through the steps of searching for the factors. And don't forget the first two factors are 1 and 24. And you give the larger one the same sign as this if you're testing. The larger one positive, smaller one negative, and you add them. But these two add to 23. So you're going to X that off. You don't want 23. So you go to the next two factors of 24, which will be 2 and 12. Again, you're going to make the larger one positive and the smaller one negative. And then when you add them, you're going to get 10. But the middle term is 2, so you don't want 10. So you go to the next two factors of 24, which is 3 and 8. Larger one positive, smaller one negative. These two add to 5. You don't want 5, it's 2 you want. So again, X that out. Next two factors are 4 and 6. Larger one positive, smaller one negative. These add to 2, which is what you want the middle term to be. At 2. I want them to add to 2. So yes, you're good to go. So it means they're going to split this 2x into these two. Minus 4x plus 6x. Or it can be 6x minus 4x. All right? So then, go back for the blue. This expression now becomes 3x squared. I'm going to put the plus 6x first. Minus 4x. And then minus by the 8. So the plus 6x from this. Minus 4x from that. When you reach here, you must always kind of double check if this will give you back this middle term, which they do. All right? Then go for the highest common factor in these two terms. The highest common factor is 3x. So you factorize the 3x out of these two terms. Out of this one, you're getting an x. Out of this one, you're getting a plus 2. And the safe thing to do is put by the x plus 2 over here. X plus 2. Then, to know what factorizes out here, you can divide this 4x by this x to be negative 4. Or you can divide this negative 8 by this 2. Anyway, take it as negative 4. You can't just put 4, you have to put the negative 4. Because, remember, these two are what's going in one bracket times that common factor. All right, stop talking out there, please. Stop talking and pay attention. Pay attention. Oh, people, look here, don't get crossing them. Stop talking. All right, so it becomes 3x minus 4 times x plus 2. And those are your two factors. But all right to that? All right, that finishes the second one. The third one now is two terms, and I said the minus there, so automatically thinking about the difference of two squares. All right? But initially, they are not two perfect squares. Initially, you have a common factor of 3. Let's go. It is 3x squared minus 27. Factorize away the common factor first, which is just the 3. So you're going to get 3 into x squared minus 9. And don't stop there. Always check to see, for example, if that can factorize any further, which it can. Because that's the difference of two perfect squares. This 9 can be written as 3 squared. So it's 3 into x squared minus 3 squared. Then you apply the rule for the difference of two squares, which is the difference of the numbers times the sum of the numbers. So this becomes 3 into, remember, don't throw away this first factor now, don't drop it off. 3 into x minus 3 times x plus 3. And that is it. But all right, good.
Yes, sir.
Beautiful. Then we'll come into this one now, which is to solve this simple inequality. Remember, when you're solving a simple inequality like this one, let me write it out. Which is 3 minus 2x greater than 11. It's the same steps. You're trying to make the x a subject. The same steps as you were solving 3 minus 2x equal 11. The same steps as if you were trying to make x a subject of that one. Same steps. The only key thing to remember about this one is that if you have to multiply or divide with a negative number, you have to reverse the inequality sign. That's a key thing to remember about the inequality one. But the same steps, you're making x the subject. All right? You're transposing everything away from the x to make x a subject. But if one of your steps is to multiply or divide by a negative number, multiply or divide. I never say add or subtract. Multiply or divide by a negative number. The inequality sign has to be reversed. You have to remember that. All right, so transposing everything away from this x. I want to move this 3 first. So my first step would be to subtract 3 from both sides. Let me write it. That's what I'm doing in red. First step would be to subtract 3 from both sides, minus 3. That's not a multiply or divide. I'm subtracting this 3 from both sides. I'll be left with minus 2x greater than 8, because 11 minus 3 is 8. Then to get out of this negative 2, I have to divide it. So then my second step would be to divide by a negative 2. So now I'm dividing with a negative number, and I have to remember to reverse that greater than sign. So then when I divide this by the negative 2, it becomes x. Sign is reversed to less than. And then this divided by negative 2 becomes a negative 4. That's my solution right there. X less than negative 4. Well, plenty of people will get x greater than negative 4, them answer, because they would not have reversed the inequality sign. So if you did that, learn from your mistakes. Remember, whenever you multiply or divide an inequality by a negative number, you have to reverse the inequality sign. All right? That is the answer there. Then it says now, determine the largest integer. The largest integer. And then we have to write the solution set, and we have to draw the number line. That's everything we have to do. All right, let's draw the number line first. Let's draw the number line first. So the number line negative 4, negative 3, negative 2, negative 1, 0, 1, negative 5, negative 4, negative 6, negative 7, negative 8. That's my number line. My critical value is 4, negative 4, so I'm putting a circle on the negative 4. I'm leaving it unshaded. Then less than negative 4. The less than means I want to the left of the negative 4. Now again, if the equal was on this, then I would have shaded this circle on the -4. If the equal was on the inequality. Since the equal is not there, I'm leaving it unshaded. That is to say, -4 is not a valid value of x. X cannot be -4. And so that's my number line. X is less than -4. All right. So they want the largest value. So what is happening here is that your x values are basically like this. X equals, they're basically like this. -8, -7. Or if they are integers, right? Integers. I'm talking about integers now. Integers. Integer x. If I want integer values x, integer. Meaning I wouldn't want a whole number. Integer x value. Integer x values will be these 3 little dots mean that it continues down this way. Then I go to -7, -6, -5. And that's it. I cannot include -4. Those will be my integer values. These 3 little dots mean that I will go to -9, then -10, and -11, and so on. So the largest one is this. That's the largest value. The largest one is that. Largest integer. That's what this is asking me for. The largest integer is -5, the largest one. All right. And I'm drawing the number line. Oh, the solution set. I'm writing solution set for this. Then to be here. Let me write it here, so. Put it over here, so. All right. So if you have x less than -4, then the solution set, just put it in a set, put it in set bracket. Solution set will be x is such that, put it in set bracket, x is less than -4. That's a solution set. When you put your solution in set brackets and you say x is such that. And this guy write about the same thing. The question, if you get a question, to write the solution set for something. You can't just give them this, you know. You have to give them that one. Put the solution in set brackets. That's what the solution set is. All right, that part finished. But good? All right. Then we come to part D. Variations question right here. This is revision work. So touching back on some variations now. This who asked me something the other day about variations. Are you? Huh? And are you? What you asked about the other day? On topic we do, and you asked me. Is which topic? Huh? Those one. You asked about something the other day. It was something that we did already. So something in vectors? No, sir, it wasn't vectors. So that topic that we did long time ago, I think it's variations. So it's variation. I asked what was inverse variation and direct variation. That's what you asked me. I said, really? So why revision is important? We do all of this already. I know you guys don't remember stuff. Yeah, that's why we have to revise. Not a problem, not a problem. That's why we're here. This one says, given that y varies inversely as x. Remember, the inverse variation was a k over. So the first variable, y, is equal to inverse as x means k over x. If instead of inversely, it was directly, then it would be y equals k times x. But inverse is k over. All right? So remember that now. And it's x, not the square of x or anything like that. It's just y and x straight. It says use the values in the following table to calculate the value of a and b. So remember, these pair of known values is what you always use to find the k first. All right? Find k first. The method that we use is one where we always find k. You don't need to find k now. There's a way to do it without actually finding the k now. There's a way to do it without actually finding the k. All right? But I'll show you the way to find the k. Continue to show you the way to find the k first until we get closer to the exam. I'll show you. When you don't ask for the key, you don't absolutely need to find the key first. You can actually do it without finding the key. But anyway, So I'm going to find K first. Use a known pair of values. Find K first. All right. So this is a variation formula, relationship. We want to find the K first. And when it is like this, it is nice to multiply the X up here and write that XY is equal to K. All this means, guys, that the product of X and Y is the same constant all the time, The product of the X and the Y is the same constant. So if we look right now, the product of this X and Y is 16, So we say the product must be 16 and the product must be 16. That's it, That's how we do have to find the K. Right? This is telling that the product of X and Y is always a constant value. And the known pair of values right here, the known pair that they give us in the table, this pair, the product, the X and Y is equal to 16. So it means that the product of the values is always 16. So the solve the result is 32 times A equals 16, right here, so. And for this one, it is B times 24, which is 24B. 24B equals 16. That's how easy it is. And you solve for the B. All right, but let's say we're going through the steps. So here, that's a relationship formula, and you want to find the K first. So using the method still, we'll find the K first. You want to say find K first. Find K first. And use a known pair of values to find the K. Is X equals 2, Y equals 8. And you plug them in this. So it means that 2 times 8 is equal to the K. So the K equals 16. So since the K equals 16, you can plug it up here, so. And it means, therefore, that this formula becomes that XY is always equal to 16. And that's now your relationship formula going forward. All right. And then now use that the first pair where X equals 32 and Y equals A right here. So this pair we're doing now. So it means that 32 times A is equal to 16 using this formula. So the A then is 16 over 32, which is a half. So the A equals 0.5 or half. And the second pair is where the X equals B and the Y equals 24. Again, this times this must equal 16. So you can write 24B equals 16. So the B equals 16 over 24, which means that the B equals 8 into this goes 2 times, and 8 into that goes 3 times. So the B is 2/3. Done. That is it. So a third question is done. One more. I'll call it a day. I don't want to stress you. And tomorrow, you guys join online tomorrow now. Huh? Oh, sorry. 5 o'clock. 5 o'clock. It's gonna be no. I go to work and stuff. I go to work. When some of the classes, I'll have them like 11 a.m. in the day. I'll announce it. Until such time, it is the same time. Just that tomorrow, I'm going to be online as well, doing the other 4 questions on the paper. All right, so we're doing 4 questions today and 4 questions tomorrow. So I'm going to do this question now. I'm going to do these 2 tomorrow. That one, and these 2 over here tomorrow. All right, and I'm going to send you the other questions for you to do. That's a question on this page. Questions on this page. I'm going to send them in the group. All right. I'll bring them. No, I send them in a group from tomorrow. They can start working on them. All right, one last question now, Carter. They are very easy question, so we shall finish this one very, very quickly. Coordinate geometry next. So that's the topic we did next, right? This we're touching on the topics that we did earlier in the year. All right, this one is very easy, coordinate geometry. So this one gives us these 2 points, P and Q. And I want us to find a series of things for P and Q. Let's go. All right, so P is a point 2, 4. And Q is a point 6, 10. First part wants the length of the line, PQ. Remember, that's a length of line formula. Square root of the difference in x squared plus the difference in y squared. Remember, it comes from Pythagoras' theorem. All right? So we're going to write PQ equals the square root of the difference in the x value squared. That's 6 minus 2 squared plus difference in the y value squared. 10 minus 4 squared. That becomes the square root. This is 4 squared, which is 16. This is 6 squared, which is 36. 16 and 36 is how much? 52. Square root of 52 units. That's it. Very good. Length of the line. All right. Next part wants the gradient of the line. Remember, the gradient is the difference in y over the difference in x. And copy these 2 points. Rise over run. Difference in y over difference in x because it's rise over run. All right, so part 2. Small m for gradient of PQ. It is rise over run. It's the difference in the y values over difference in the x values. It's rise over run. The rise is the difference in the 2 y values. I'm going to subtract it one way. Let's say we're subtracting it this way. You have to decide which direction you're subtracting. You have to stay consistent. So it's this y value minus this y value. 10 minus 4 over this x value minus this x value. 6 minus 2. That becomes, this is a 6. This is a 4. Which reduces to 3 over 2. So gradient of PQ is 3 over 2. All right, so those 2 done. Next part wants the equation of PQ. So remember, to find the equation of any line, you need to know 2 things about it. Gradient and a point. So you can use a BFF formula. All right, so for part 3, we have the point P. Let's say we're using the point P. You can use any one of them, but I'm going to use the point P. I'm going to use the gradient of PQ, which is 3 over 2. And the equation becomes y minus yp equals the gradient of PQ into x minus xp. So it's y minus, the y value of p is 4 right here, equals the gradient, which is 3 over 2, into x minus xp right here, that 2. Now, because this time is going to give me a whole number, I'm going to multiply inside here. So I'm going to have y minus 4 equals 3 over 2x. And this time, this is going to give me a negative 3. Then this 4 comes over here and comes a positive 4. 4 minus 3 is 1. So the equation is y equals 3 over 2x plus 1. That's the equation. All right. Nice and easy. The next part wants the midpoint M of PQ. My midpoint is like an average point. So the midpoint is just like an average point. All right. See it here now. Midpoint. M. Remember, it's the average of the x values and the average of the y values, give it the midpoint. So you're averaging these two x values. That's 2 plus 6 over 2. You're averaging these two y values. That's 4 plus 10 over 2. And so the midpoint is 8 over 2, which is 4. This is 14 over 2, which is 7. So the midpoint is a 0.47. That's the midpoint. Done. Very good. The next part now says we have to determine the equation of a line through M, which is perpendicular to PQ. That is called the perpendicular bisector of PQ. For the line through M, that is perpendicular to PQ. So I'm going to sketch it up for you now. So it is like you have P here and Q there. And we worked out the point M, the midpoint M. And they're asking us to find this line in red. That is called a perpendicular bisector. It crosses through the midpoint, passes through the midpoint, cuts the line in 2 equal half. That's what I mean by bisector. And it is perpendicular to it. So we need to know 2 things about this red line now. All right? We need to know 2 things about that red line to get the equation. The 2 things we need to know the gradient and we need a point. The point is clearly M, but we know the point M already. As it passes through the point M, we just calculated a while ago. It was 47. So the red line passes through the point M, 47. The next thing we need about this line is a gradient. Let's call it line 2. Let's call this line 2. They're asking us for the perpendicular bisector. Now, because it's perpendicular to PQ, then the gradient of line 2 is -1 over the gradient of PQ. What's the gradient of PQ again? Gradient of PQ, remember, what was it? 3 over 2. It was 3 over 2, right? We have it up here. Gradient of PQ was 3 over 2, yes, 3 over 2. That's what we have here. And so the perpendicular gradient is a negative reciprocal of that. So to get this perpendicular gradient, this quick calculation is to flip this and change the sign. So this calculation on this gradient is going to result in that perpendicular gradient being -2 over 3. Flip the one that we have and change the sign. So we're using this gradient and this point to get the equation of that red line. All right? So the equation of line 2, the perpendicular bisector, is y minus ym, because it passes through the point M, equal to gradient, perpendicular gradient into x minus xm. So it's y minus, the y value at the midpoint is 7. The perpendicular gradient is -2 over 3. Into x minus, the x value at m is 4 right there. To simplify this quickly, we can take this 3 and multiply it across here by these 2 values. And then take this -2 and multiply it inside this bracket. All right? We'll take the 3 first and multiply it across here. We're going to get 3y minus 21 equal to -2 now multiplied in that bracket. I get -2x plus 8, but the -2 times the -4 is just +8. And then now we're going to transpose this 21 over here, add it. So we're going to get 3y equals -2x plus 29. Because the 21 and the 8 makes 29. That is the equation. If you want to divide through by this 3, you can divide each term by 3. But it is okay to leave it like this as your answer. But good at that?
Yes,
Then
sir.
this last part now, this last part now is asking us for parallel lines. The parallel lines have the same gradient. So in this case, this last part now, it is as if you have your line PQ, and like this. and you want to find another line that is parallel to it, bam, but passing through a point R, which is -2, -3. Let's call this line 3 now, the third line that's asking us to find, line 3. To find the equation of that third line, let's change the color. It's in purple. To find the equation of that third line, you need to know two things about it. You need a gradient and a point. It gave us the point that it passed through. Right here. To get the gradient, we're going to use the fact that it is parallel to this one. Remember now, the gradient of PQ is 3/2. Parallel lines have the same gradient. So the gradient of this line is also 3/2. So the gradient of this third line is equal to the gradient of PQ because they're parallel, the same gradient of 3/2. Using this gradient at this point now to get the equation. All right, so the equation of line 3 that we want is y minus yr. R is a point, equals the gradient of line 3, which is the same as the first line, into x minus xr. Careful with the negatives now. So it's y minus, the y value at r is -3. -3. So this becomes a plus. Equals the same gradient as the first line is 3/2 into x minus x value at r is now a -2. -2. So we have two pluses here. This is a plus, that's a plus. This minus is a plus, this minus is a plus. So again, because when I multiply this by this, I'm going to get a whole number. I'm just going to multiply this inside here now. So I'm going to get y plus 3 equals 3/2x. What is that? 3/2 times a +2, you know, so I'm going to get a +3. What I go to that? Then this +3 cancels this +3. So I'm just getting a line, y equals 3/2x. And there's no C value. But so we're going to pack up. I'm going to register it. How is father? And that is it, guys. So watch me now. If you didn't do the question, you need to go and do it for me, please. All right? Go and do the question for me, please, if you didn't do it. I'm going to send the video in the group right away. Make sure you do the questions. Someone let me a pen, please. Someone let me a pen. All right. All right, Luke Smith. Kai Williams. Rihanna. Xavier. Jaden Reed. Elizabeth. Rickon. McEwan. Malik Mills. Malik Mills, where do I say name? Newman. Zachary. Alex. No, Alex King. Christoph Duncan. Jadine Smith. Ace Reynolds. Justin Bowen. Justin Bowen. Cristiano. Dominic. Shakim. Alicia. Akil absent. All right, Russell. Dejane Jackson absent. Jennifer Davis absent. Adrian Maynard no longer here. Dejan Brown. Samuel Mason present. Dante present. Rashid Williams present. Zara Connor present. Giovanni Dixon present. Daniel Lynn online. Daniel Lynn online.
Yes, sir.
Jamal Sewell present. Ryan McIntosh. Ocean Dallas present. Candice Acosta present. Aston Carr absent. Alex Robinson present. Amelia Atkinson absent. Shaquille Brown present. Paris Dixon present. Alrighty. All right, guys. See you all tomorrow. You guys must join online tomorrow now. Join online tomorrow, 5 o'clock. Here. Yeah, all right, cool. Bye, everybody. Write your name on a piece of paper, wrap it up in there for me. Write your name on a piece of paper. I'm in the class. No, you have Alex King, you have Alex Robinson. All right, bye.